Of today, it's Davlet Dzhakishev. He's a CEO and founder of Cloudgeni, and he's going to talk about from finding to fixes, how AI can and cannot make cloud infrastructure security scanning actionable. Thank you very much.
Yeah, thank you. Great to be here. Thanks, Tekna, for inviting to have us talk about what we are very passionate about, me personally. And so, yeah, I think what Daniel and later Fu shared already actually mirrors a lot of our findings in the space. So that's great, to be in the company of great companies and prominent scientific institutions and come to the same conclusions, a lot of same conclusions. But what I bring today is a more practical angle for practitioners. How can they use the generative AIs to solve concrete problems? And today we're talking about cloud infrastructure specifically, right? So we touched upon physical infrastructure, IoT. So now it's a great. Now we're going to cover basically all bases. And my knowledge from it comes mostly from my 15 years of experience as a software engineer, as a CTO and a tech lead on a few startups as well. And when sort of Gen AI revolution started 3 years ago, that was I saw an opportunity to solve a lot of problems that I saw in industry that were not possible to solve before, just by the sheer volume and amount of those problems. So cloud, and today I'm mostly speaking about hyperscalers, AWS, Azure, GCP, but also some other bigger players. They provide a great tools for us to use to deploy our resources in their environments. However, it is up to us, up to engineers, to configure them in a way that is secure, that is prevents any unauthorized access. And it is still a problem. So more than 90% of the misconfiguration, security breaches in the cloud happen due to human misconfiguration. So something was not properly set up, and oftentimes this leads to disastrous consequences. So this is some of the examples that happened exactly due to those misconfigurations, right? Where a firewall wasn't configured correctly, AWS S3 bucket wasn't set to private. All this led to customer data being leaked and unauthorized access to sensitive data, and even a man-in-the-middle attack. However, these issues usually get less attention from the industry at large because they somehow seen as boring, as unimportant, as unlikely to happen, because people put too much trust in the cloud itself or those hyperscalers, thinking that if they are there, they can be pretty much secure. That is not the case. So, and the second problem is this fatigue of all the problems, right? So you have many excellent tools that will scan, that will drill down into your cloud operations, will find all possible vulnerabilities in it. You will end up with thousands of alerts, and that is literally thousands of them, which engineers are then left with sifting through, understanding what are priorities, which is just a noise. A lot of false positives. However, you never know until you have spent time on it. So until now, basically, companies just close their eyes on this and hope for the best, right? You try to make your best effort. You decide what's your threshold that you're comfortable with, the risk ratio, and then you just roll with it, right? However, during seeing those breaches, it's not enough. And then one more angle that I want to bring before I go to the next slide. Now with AI, it is also easier to do attacks, right? It becomes cheaper. It becomes more accessible for anyone to just try and test your systems. Before, it would require a lot of knowledge, resources. So that's why usually the targets of those attacks would be larger institutions that will have a larger payoff. Sorry for this. However, now anyone can have access to an excellent tools that can just penetrate and stress test your infrastructure. So the threshold is lowering, so these issues cannot be ignored anymore, even by smaller companies that don't have resources for dedicated security teams and dedicated cloud security operations. So this is why you beat AI with AI, right? Now you can, the promise is, well, let AI deal with this as well. In reality, though, and may have maybe tried already, it's not that simple. So we've maybe tried it for our way of line of work, right? Rather, it's a presentation, maybe some code, maybe something else. You have find the same problems. Overconfidence bias, right? It will present you with a solution that it will confidently tell you it is a solution, which in reality it will not be. Context ignorance, unless you provide it with a lot of on context to solve certain problem, it will just guess, and sometimes those guesses will not be in your favor. Specifically for infrastructure, it is a critical area to touch. So a small configuration change can lead to cascading disastrous consequences, right? One private network that's been set to not accept internet can lock down the whole of your infrastructure, and your all your services are down. So scaling risk, yes, and organizations are still figuring out how to use AI responsibly. Where can they trust it? Where can they not? Right? What tools are we allowed to use? We are still having this gap in both education and deployment. So here I just wanted to show like a very small example of what I'm exactly talking about. And this is going to be maybe a little bit too practical, but I think sometimes it's nice. So here is a repository with a Terraform code, which is infrastructure as a code, which describes your infrastructure details in declarative language. It's a popular tool for cloud engineers to be able to have control and visibility over their resources in the cloud and be able to use GitOps to manage complexity and have eyes on it and collaboration. And then I will run a simple popular static analysis tool, open source, that will scan my code and will report all the potential vulnerabilities in it that it can find, just looking at the code, right? So we can see some of stuff passed, and then there are some issues that it found. And if we try to find like some simple enough problem and use Copilot, GitHub Copilot to fix it, right? We let it run a little bit. It will try to read the context now. Even simple generic AIs use some agentic capabilities, meaning they will actually try to read your whole infrastructure and then solve the problem. So it found the correct virtual machine and then applied some fixes. Right. Looks good to me. I asked it in virtual machine should have encryption at host enabled. It did that. I'm happy. Let's try to run Terraform plan. So whenever I want to apply those changes to my cloud, sorry, I need to go to. I need to make sure that I can run all the tools and tests before it, and that Terraform plan will provide me with the list of changes that will happen to my cloud infrastructure after I made these changes. Okay, I get some errors. Right, so what's going on? All right, okay. So if you look into the documentation for for Terraform, for Azure provider, we will see if I want to enable encryption at host. This is the variable it needs to be, encryption at host enabled. The Copilot confidently provide me with a fix that says encryption at host equals true, right? That is something like an engineer would just spend 5 seconds checking the documentation. Agent that has access to the internet, that has vast knowledge, wasn't able to do a smallest possible fix, right? And I have a theory why it could be, is because it conflates a lot of different sources, right? Here is the documentation from Microsoft Azure, how you can enable encryption at host via CLI, command line interface. So there is no enabled line. So it basically hallucinated the configuration name, and we see it often and often, again and again. Yeah, so how do we battle that? How can we trust AI that fails at even the smallest possible tasks if we want to solve something more potentially critical and complicated? Yes, and then it can even get worse if we consider that the work that is done by engineers with the help of AI can actually contain those vulnerabilities. It can be confidently telling you this is the correct code, but actually provide you with insecure configuration. So on top of human errors already, we can end up with more errors with unsupervised changes in AI. It is not all gloom, right? We are AI company in cloud infrastructure space. So why am I saying all these things? So let me walk you through how can we prevent this from happening. Basically, we treat today AI tools, they are writing code oftentimes in the notepads, the way that I see it. The way we can help AI tools to write and produce the solutions that are more in line with our expectations, we need to provide them with better tooling. So they need to be aware about our policies, they need to be aware about the context that they're operating it, they need to be aware of the latest documentation, and have access to the same tools that engineers have to be able to do that. And it is still important that human still is in the loop. And I think I parrot here both Daniel and Fu that this is crucial moment. So, but how can we still have human in the loop? Like if we still have it, we are not solving any problem again. So let me sort of show you how we look at this problem in another demo. So our approach. What we believe in, again, is an AI that can have access to already existing findings, right? We already have access to amazing tools, scanners that scan problems in your cloud, and potentially there is a lot of them. And if we take a similar problem that we saw earlier with the virtual machine that's host enabled, so here is the same problem that is shown in the dashboard here. And then I can view remediation of this problem directly in our AI. And then what it did is it did all the things that I mentioned to you, right? It had access to the tools like Terraform Plant and Terraform Init, Terraform Validate. It had access to the open source tools to scan, to validate the works. So, and then it explains to the human in the loop the work it did, why it did it, what are the implications. And so it both as educational, but also as a way to bridge the trust, right? And once we have this validation status, we are certain that the correct variable will be set there, guaranteed every time, 100% of the time, right? Because otherwise it will just not run those tests. And that means we can run those fixes on much more complicated problems that require much more moving parts. And again, in collaboration with human, we are not changing environments without their oversight, but we are helping and providing with all the context that might need how this change was done, and so that we can trust AI with much more significant changes, and we can trust them with something more complex. So here is some of the thoughts on this how it can be used. So yeah. So still, I think the adoption curve is going to take time, right? So what we are starting today is lower risk repetitive tasks, right? And that's one of the reasons why we chose compliance as a space, because it is relatively known, it is relatively agreed upon how the infrastructure looks like when it is compliant to certain standards, like ISO 27001, SOC 2, NIS2, and others. It only creates suggestions like pull requests, right? Things like that human engineers can look at. And the goal is to reduce cognitive load, to not completely remove human in the loop, but reduce the work on the research they need to spend looking into this feature or problem, and provide with a final solution that they can just validate and decide when it's ready to be deployed. And you still need a human oversight, especially closer eye in the high-risk infrastructure changes when it comes to organization-specific rules and the decisions that don't have one single correct answer, but more of a trade-off between different parts of the system, right? Reliability, cost, security. Yes, I think this is pretty much a repetition of what we do. Yes. So I think I'm positive about the industry as a whole, right? So we've so far we've been focusing on scanning and finding vulnerabilities and processes around how to treat them. Now we can actually start looking into how can we turn these systems into complete, whole, secure, and compliant in less amount of time with less amount of resources. And this guardrail constrained AI can help us in that. So yeah, I think this is my final sort of message, I guess, is to try and give a chance to our new teammate. They're still learning, but with the right tools, they can do a great job. Thank you.
Thanks a lot. That was very interesting. Do we have questions from the audience? I don't have anything on Slido, so yeah, up there. Maybe Fu can go first.
Yeah, thanks a lot for your presentation and also a great live demo. I think it's interesting to see a live demo anyway. For me, I wondering in your demo, I don't know if you do you use some kind of standardized or let's say standardization like Oasis Tosca, for example, as input for your kind of AI based analysis, or is because I go a little bit on the Tosca technical committee for a very short time, but I think it's I don't know if it's relevant for your work. And did you use something like that or make use of something like that?
How would you like you mentioned, how did you say it again?
The Oasis Tosca. It is a kind of topology and orchestration for cloud-based architecture, right? So it's quite.
Yeah.
Maybe you.
Yeah.
If you.
Yeah, we use it in some way, right? So to be able to make those fixes in a good way, we need a lot of data sources. We need to understand the whole context of your infrastructure as a code. Yeah. We need to understand the topology of your cloud infrastructure, how resources communicate with each other, right? What is managed by your infrastructure as code, what is not managed by your infrastructure as code, what are the sort of relationships, which resources can depend on each other. And then in addition to that, documentation that is relevant, for example, for this infrastructure as a code, for this cloud provider, for this version, right? So there is a lot of things going on, but this is one of the signals that we use to actually provide the most possible correct fix. Yeah.
Yeah, thank you very much for the presentation. It was clear, and I really enjoyed this practical parts. I think I have maybe a philosophical question, but it's back to my first question. So we are repeating that we need a human in the loop. How do we deal with the cognitive bias that being humans, we're actually beneficiaries of this way of thinking? And
they are...
we are benefiting from this way of thinking because we want to keep human in the loop.
Yeah.
And we are humans.
Yeah.
So we kind of don't want to take ourselves out of control. So it would be interesting to know your opinion on kind of challenging this approach.
I truly believe it's not just me pandering to developers and the community. Honestly, I do think it's important to have. And this was our finding. Like it's very easy to get like into this tech mindset, or everything will be better if things operating themselves. And I think for certain low risk operations, non-important stuff, it is probably true, like mundane things. For critical things, I don't see us going away from it. Airplanes been flying themselves now for several decades. We still have 2 pilots monitoring it and jumping in if something goes wrong. So I think our ability to react to unpredictable, to new situations, our adaptability will be relevant until, of course, edge AI. But I also don't think with the current models, edge AI is actually achievable. So what we're gonna see is better, more reliable tools, vertical AIs, at least, unless there is gonna be some new research, the new foundation that is built. So until then, the way I see it is more building the constraints and guardrails and tools to help current sort of architecture and LLMs to perform best possible in those different domains. Yeah.
I actually got a few questions on Slido now. We are just very slightly over time, but I think it's great if we take maybe a couple of questions. The first one is from Gretel, you're back. That's amazing. How do you see agentic systems evolving to test, simulate, and self-correct such infrastructure code safely before deployment?
Yeah, absolutely. And I think this is like the first glimpse of what you see, right? So right now we just run it in ephemeral environments, right? The next step is actually to maybe deploy it to real environment, to test it, to validate this, and then you can actually trust it more that you've already run it against sort of real test environment, and then your changes will be acceptable for production. So this is absolutely the next steps in this direction.
Okay, thank you. Then I can go to the next one. We have engineers who are trained without AI. But what happens over time when using AI? There's no cognitive load, and this leads to oversight by these engineers that they cannot really think anymore.
It's a challenge. I'm not gonna say it's not. I think there is gonna be definitely a transitional period. Right now, it's not a problem because most engineers that work today, they were educated and worked for a while without AI. The way I see it is two ways. I think we need to be able to collaborate with AI. Right, this is going to be the main skill going forward, being able to learn quickly, and then AI can help you to get educated more. Right, so this is going to be more intentional to treat it not as a sort of something that you rely on all the time, but use it to learn. So this is where I think we can stay on top of things, but it's a challenge, right? It's always easy to go with the easiest path, but for some things, the easiest path will just be not enough, right? Someone will still need to understand and have intent about the systems, right? AI cannot have intent. So humans need to have, but to have intent, you need to have some understanding about what you're trying to achieve. And to do that, you need to understand at least something about the systems.
Okay, and we still have 2 questions from Gretel, but I'm sorry again, I have to take only one of them. Next time, just come here so you can discuss with us in person. That's amazing. Oh, you're here. Oh, you're here. Sneaky bastard up there. Okay. Well, then I take the first one, and then the other one you can just go ask this handsome guy here. So, what types of AI-driven security tools or architecture, do you believe will be most effective in defending against AI-powered attacks in the future? Because, as you said, we use AI to defend ourselves, but the attackers as well use AI.
I mean, interestingly enough, I do think that those tools that can automatically find vulnerabilities in your system can be used, right, to find those, and then using this information, we then can feed to a white hacker AI agent, right, to try and find solution to those. So So I think that it actually starts with this finding those problems, right? We are lucky that we actually already have access to all these security tools that we can already use data from, both open source but a lot of commercial ones. So we don't need to build these capabilities ourselves. We just rely on signals from those. But however, going forward, as maybe problems are going to be more and more harder to detect, we might see that we will need to, build AI that just in a sandbox just tries to find all crazy things. And I already had conversations with few startups that are actually building something like this, right? Like pen testing tools that just go crazy and can run millions of different combinations to try to find breaches that wouldn't be possible otherwise.
Perfect. Thanks a lot. Let's thank him again.
Yeah.